All right, this is an introduction to fractions. So starting out with what does equivalent fractions mean? So equivalent, this beginning part looks a lot like the word equal. So it means the fractions are equal to each other. You see our example over on the right, the half, 2/4, and 3/6. You see the picture, all of them are really the same fraction, just written in different terms. Okay, so the way you take a fraction and turn it into equivalent fractions is you need to either multiply both the numerator and denominator by the same thing or divide. So in this example, we're multiplying. We get 6/8. The reason this works is because if I multiply by 2 over 2, that's the same thing as multiplying by 1. Okay, so 2 over 2 is really just a big 1. I'm multiplying 3/4 by 1. So 3/4 is equal to 6/8. It's the same thing. It's just written in a different form. It's written in eighths instead of fourths. So that's equivalent fractions. So take these sets of fractions and you're either going to have to multiply or divide both the numerator and denominator by the same number to figure out what all these missing ends are. I'll show the first one. The first one, to get from 9 to 27, you would multiply by 3 to get 27. So since I'm multiplying that by 3, I'm going to multiply this 4 by 3 also, and that means n is 12. So go ahead and pause and try the next 3 on your own and then hit play to find the answers. All right, this one, it's going down, so that means I'm dividing, and I'm dividing by 3. So if I divide 45 by 3, I get 15. On this one, it's also going down, and that means I'm dividing by 7 to get to 8. So if I divide 28 by 7, get 4. And the last one, 9 to 90, I'm going up, I'm multiplying by 10. So this n is 440. So that's equivalent fractions. Equivalent fractions are also helpful when you're talking about putting fractions in order from least to greatest. Right now, all our denominators, the bottom numbers, are different, right? 4, 6, and 18 are all different. So it's not very helpful for comparing the numerators. I want to have the common denominators, so then it's easier to compare. So if I look at my numbers, 6 can go into 18, but 4 can't. So I'm going to try doubling 18. So if I double 18, I get 36. And both 4 and 6 can go into 36. So that's going to be my common denominator. 6 times 6 is 36, and 4 times 9 is also 36. So then I need to multiply the numerators by the same thing. So this would be times 2, just like the 18, times 6, and times 9. So here are all my equivalent fractions to the one above them. And they all have a common denominator, so now I can just look at the numerators to put them in order. So 14 is my lowest, so that's representing 7/18. 30 is next, which is 5/6. And then 3/4 is the 27, so that's the largest. So here are my fractions in order from least to greatest, thanks to my common denominators. So go ahead and pause it. Try this one on your own, putting them in order from least to greatest by finding equivalent fractions. All right, so let's check it. Your your common denominator should be 30. So this would be times 6 for 4, times 3 for 10, times 5 for 6, and times 10 for 3. So these are your equivalent fractions. Make sure they're correct. And now I need to look at my numerators to put them in order. So that means 1/3, which is the 10 is the smallest. Then the 7/10 is next, followed by 4/5, and finally 5/6. So those are my fractions in order from least to greatest using the equivalent fractions. All right, next we're going to talk about improper fractions and mixed numbers. Both of these represent numbers greater than 1. So both represent numbers greater than 1. So when I'm talking about an improper fraction, the way that represents a number greater than 1 is that the numerator, the top number, has to be bigger than the denominator. So numerator bigger than denominator. So an example of that would be 7/5, right? My numerator is bigger than my denominator, so that means it's greater than 1. There's more fifths than one whole, which would be 5 out of 5. Mixed numbers are the same idea, although instead of writing it as an improper fraction, it's a combination of a whole number and a fraction. So combination of a whole number and a fraction. And since both of these improper fractions and mixed numbers represent numbers greater than 1, you can convert between the two. So my example this time would be 7/5 written as a mixed number. So 7/5 is really 1 and 2/5. That's a combination of the whole number and the fraction. All right, so let's talk about switching between the two some more. So here's some harder improper fractions and mixed numbers to convert between. So look at this first one, this improper fraction. Remember, that means division. Fraction bar is division. So if I want to turn this improper fraction into a mixed number, all I need to do is divide. So I'm going to take my 785 and divide it by 3. So go ahead and do out the division. And then when you get to this point, we talked about before when we were doing decimals, adding a 0 and continuing. But since we want the fraction, we're not going to continue. What you're going to do is take what you guys would typically call the remainder, and you're going to take the number dividing into it, the 3 in this case, and you're going to make a fraction. You're showing that 2 still needs to be divided by 3. Okay, so that remainder becomes your numerator, and then the 3 becomes the denominator of your fraction. So this is your answer, 261 2/3. This is equivalent to 261 2/3, showing that there's 2 that still needs to be divided by 3 left. So that's turning an improper fraction to a mixed number. Next, let's go the other way. We have a mixed number. I want to make it an improper fraction. 5/6 are your fraction. The only part I need to change is the 35. Right now, 35 is a whole. Any whole you can put over 1. So there's 35 over 1 as a fraction. But I need it in sixths, right? Our fraction is sixths. So remember, I can do equivalent fraction. If I multiply both by 6, I'll get 35 into 6. So I'll figure out that 35 times 6 is 210. So instead of writing 35, I'm going to write 210 sixths. And then I need to include the 5/6, so add in that 5/6. So altogether, I have 210 plus 5 more is 215 sixths. Okay, so turning it into an improper fraction is 215 sixths. You first just need to change your whole number into an equivalent fraction with the same denominator and then add them up. All right, so go ahead and pause it and try turning this improper fraction to a mixed number and the mixed number into an improper fraction. Then hit play to check your answers. All right, so remember this means division, so 37 divided by 4 goes in 9 times with 1 left over, so that's going to be 1 divided by 4 left over. So 37 over 4 is 9 and 1/4. 8 and 5/9, the 8 needs to become ninths, so I'm going to multiply them both by 9. All right, that should be times. So I get 72 ninths. Don't forget to add in the 5 ninths I already had, so altogether that's 77 ninths. So that's turning mixed numbers into proper fractions and vice versa. Finally, let's practice some word problems that have to do with fractions. Sam and Harrison prepared 40 sandwiches for a picnic. For 14 friends. If the sandwiches are evenly divided among 16 people, how many sandwiches would each person receive? So we're taking 40 and we're dividing it evenly by 16 people. Okay, so this is one of those where you try trial and error. Maybe try 16 times 3 to see how many times it goes in. That's too much, so it must be 16 times 2. Okay, so 16 times 2 is 32. We do our subtraction, and at this point, remember, we're not turning into a decimal, we're turning into a fraction. So I take my remainder of 8 and show that it's being divided by 16. So that's my answer, but you want to make sure you simplify your answer. Simplifying is using the equivalent fraction that's in the lowest terms. So both 8 and 16 can be divided by 8. So that means I could simplify this. There's still 2, the 2 doesn't change, and 1/2. So 2.5 sandwiches is how many each person is getting. that's your fraction basics.